once you initially intend doing this particular approach, you inform the ATC that you are in bad weather and you intend approaching the aerodrome with the assistance of the radar or the radar assisted approach, whatever the case may be. And once the ATC has got, once the ATC gives you okay, carry on, and you will be thereafter, the approach control will hand you over to the so-called surveillance radar. The surveillance radar will pick you up and start. Thereafter, once you have been identified by the surveillance radar, there are various means of identifying the aircraft, telling the aircraft to either turn left, right, etc., or maybe with the help of the SSR, etc. Once the aircraft has been identified, you will be guided towards that particular aerodrome. Now, this particular radar has got only the azimuth control. No vertical control is, as far as the surveillance radars are concerned, they control the aircraft in azimuth only. That means left, right, etc. They cannot control the aircraft in vertical. As such, you will be verbally told, okay, carry on approaching, and now you can descend down to so-and-so particular height. During this particular phase, when you are in the surveillance, with the surveillance radar, you will be given the complete brief on the various weather conditions, the QNH, runway in use, surface, wind, all whatever the weather information is normally given to you during the approach. All the information is given to you. In case there is any additional information, ATC will provide you that. And one of the main part of the so-called briefing by the surveillance chap is, in case you have an emergency on board the aircraft during the radar approach, especially during the precision mode. If you have an emergency, what are you supposed to do? Especially in case of RT failure, communication failure. If it is there, what are you supposed to be doing on? Because thereafter you are totally on your own. You can't hear anybody, you can't see anybody, you can't do anything. As such, once you're all your own, the complete briefing will be given to you. The aircraft, the surveillance chap will guide you up to the downwind. Thereafter, you will be asked to carry out your downwind checks. Once you have carried out the downwind check, the surveillance chap will say, okay, now I'm handing you over to the precision radar controller. As I mentioned in my previous class, as far as the precision approach is concerned, it's totally like instrument landing system. Only thing is, in this particular case, you as a pilot are supposed to just follow the instructions given to you by the precision controller, because the precision controller has got two screens. One is the localizer screen and the other is the glide path screen. And those lines are drawn on that. And the job of the controller is to keep the aircraft on that particular line. This is what you exactly do. And you make an ILS approach on your own. You're supposed to look at the instrument, and thereafter turn the aircraft left, right, up and down, whatever the case may be. Similarly, in this case also, you are guided, and once you have been handed over, obviously you will be identified. Once you have been identified, you carry on, confirm downwind checks over, etc., etc. Thereafter, turn base leg now, heading so-and-so, turn finals, maintain heading so-and-so. Once you have turned finals and you have settled on the finals now, you will be asked to maintain total RT silence. Thereafter, you are not supposed to be responding to any communication between you and the ATC. The ATC will keep guiding the aircraft depending on what your actual position is in relation to the glide slope and the localizer, left, right, etc., etc., etc. You will be guided, and the aircraft will be brought down what we term as up to the decision height. Approaching decision height, you will be warned earlier that we are approaching the decision height now. Now we are at decision height. Do not descend any further. Confirm runway in sight. Obviously, you'll be looking out. You and co-pilot, you'll be looking out now. If you have got the runway in sight, You will say, okay, runway in sight, carry on your approach and clear to land the aircraft, etc., etc., etc. thereafter. But if you do not have the runway in sight at the decision height, you will be asked to open power, go around heading so and so. The complete radar approach is on QFE. Now I want the class to give me the answer. What do you mean by QFE?
Is the altimeter setting which indicate the elevation, which show the altimeter setting 0?
That means height, or in other words, that is in case you are on ground, the height will show 0. But if you are flying, height above the ground, whatever the height is above the ground will be shown to you there. If you set the QFE on ground, it will read 000. But if you are flying the aircraft and you have set the QFE, then whatever height you are above the ground will be indicated to you. So all radar assisted approaches have to be on QFE. Any questions, anything? As I said, what I forgot to mention is as far as the precision radar is concerned, that controls the aircraft in azimuth as well as vertical. And the surveillance radar controls only the aircraft in azimuth. Can you have a look? Can you go to the last page of this particular book, of this particular chapter? Radar assisted approach in the GCA. Can you go on the last page, please?
GCA or GCS?
It's GCA. GCA, ground control approach. Last page. One before this. One page before this. Yeah, this one. When we talk about the termination of the radar surveillance, sir, can you change the font a bit, please? Make it a bit larger. Yeah.
Okay, sir. I gave you the control. You can control the screen.
Okay. I can't. I don't have the control with me now.
Can you try to move your cursor?
I'm moving my cursor now, but the thing is not moving at all.
Okay.
Can you give me the control, please?
Okay. Control.
So far, I can't.
Okay. Is there any notification say that you are given control?
Click to start the mouse.
Okay.
Are you controlling or am I controlling?
You are controlling, sir.
Am I controlling?
Yeah, you are controlling.
Okay, thank you so much now. Okay, then when we talk about the final action is, when you terminate the radar, it says the termination starts at in normal case, if you're using the normal radar, it's 2 nautical miles, normal resolution, and in case you're using high resolution radar, then the termination is 0.5 nautical miles from the touchdown. Have a glance at the whole system, and in case you people have any questions to ask regarding the surveillance radar, I'll try and explain them, please.
Okay, sir.
Any news? What is the news on when are we coming back? Any idea?
Sorry, sir.
Any rumors? No news, any rumors? Any rumors or something like that?
What we decisions expected to be made in the next 2 days, sir.
Yeah, I know. The 10th, they have said that they'll make the decision on 10th, and what we hear, I don't know whether I'm correct or maybe I may be wrong. I do not know. What they are saying is, even if they open up the institute, the education institutions will stay closed for some more time. And I believe MFA falls into the category of educational institutions. I don't know exactly what the case will be, but this is, I'm just don't give any sort of importance to what this information is, because we are not very sure whether this information is correct or not correct.
Yes, sir.
Anyway, let's see. In case it is increase, you just what I suggest is you make the program for the next week also, thinking that we are otherwise we are supposed to be back on 15th.
I think supposedly we also need to be extended because according to the flight logger, say that only the flying batches will be coming back first. The ground school should be coming back later.
Later.
Correct.
Okay. Anyway, then you make the program for the next week also, please. Accordingly, whatever I said, give me 1 hour 30 minutes at the end, 11:30 to 1 o'clock every day.
Sure, sir.
Okay. Now this is now we have got the so-called various type of radars in use today. These are the various type of long range surveillance radars, terminal area surveillance radars. These surveillance radar are divided into 3 different categories. Then you have something known as a precision radar. We have got a movement, surface movement. This, of course, is very rare now when you talk about the surface movement radar. Here, in case you have at the aerodrome, if you have a surface, especially at night time, when the aircraft cannot be seen by the air traffic controller, you can see the aircraft onto the radar screen. And the weather radar obviously are normally used by the Met people who give you the prediction on various weather conditions depending on. So here, of course, there is there. I'm sure you have no questions as far as this is concerned. What we are interested in is what we term as the airborne weather radar. This is one thing which you're going to use, as I mentioned, right from the day you start, once you enter the cockpit, after you finish, after you graduate from the academy, and once you join the airline, and once you start flying the airline, or maybe even during the simulator phase, you will be doing what we term as, or you will be using this particular navigation system, which is called airborne weather radar. Now, before we commence, before we start on the topic, my question is, what is the purpose of having airborne weather radar?
To trace for the CB clouds.
I beg your pardon, come again?
To trace CB cloud.
To trace thunder cloud or CB cloud or cloud which are going to cause turbulence, right?
Yes, sir.
Now, this particular weather, in case you can you come onto the page, please? Airborne weather radar, page 1.
Chapter 14, sir.
Is it chapter 14?
Okay.
I think it's chapter, as per my record, I don't know. These books are slightly different. Yeah, airborne weather.
Okay, sir.
There we are.
Sir. Okay.
Can I control them now?
Sure, sir. Can you move on the cursor? Okay, you're controlling.
Okay. No. Yeah. Airborne weather radar. Now, before I go into the main topic, there are various functions of the weather radar. Number 2, what I want to point out here is when we talk about the cloud formation, all clouds are not dangerous. All clouds are not dangerous. The main purpose of weather radar is to identify the weather and know the exact location of the weather. Once you are sitting in the cockpit, once you are flying the aircraft, the Met will give you a general briefing. Okay, on your route you might be having Charlie Bravo, etc., etc., etc. But Met cannot possibly give you the precise location. You may have the general idea or the general area where the weather is likely to be bad. Met may give you the forecast. But once you sit in the cockpit, you want to know the exact location where the cloud is. As I mentioned, I repeat, all clouds are not dangerous. Now, when you talk about the cloud or the danger of the cloud or the turbulence in the cloud, that depends on the size of the water droplets in the cloud. The larger the size of the water droplets, more is the turbulence. When we talk about size of the water droplets, these water droplets invariably, the larger size is about 3 centimeters square. When you talk about large, the turbulence is totally related to the size of the water droplets. Starting from 1 millimeter, it almost goes to up to 3 centimeters square. If you have a 3 centimeter square water particle in the particular cloud, this particular cloud will be obviously considered to be very, very turbulent. Now, as far as the weather is concerned, as I said, all clouds are not dangerous. So as such, when we talk about the weather radar used in the cockpit, when you're sitting in the aircraft, and when you are flying the aircraft, for locating cloud ahead of the aircraft, you can see the cloud picture ahead of you on your screen. Once you put the weather radar on, now the main purpose here is to distinguish between a particular turbulent cloud or cloud which is not considered dangerous. You can fly through. So this is, you have to identify. We will go, once we study this particular article further on the weather radar, we'll be able to find out how can you identify. And the further use of this particular weather radar is to determine the approximate height of the cloud relative to the aircraft. That means you sitting in the cockpit, you can identify what is the height of the top of the cloud. And the last usage of the radar, weather radar, is in case of reasonably okay weather conditions, you can carry out map reading with the help of weather radar. These are the 4 distinct uses of the weather radar. Number 1, locating the cloud, then distinguishing between which is bad, which is good, and thereafter, then you can determine, in case you want to determine the height of the top of the cloud ahead of you, you can do this by the help of weather radar. And obviously, the last is, in case of reasonably okay weather conditions, you can carry out the weather map reading also with the help of the weather radar. These are basic as far as the functions of the weather radar. Nowadays, you have 2 types of weather radars on board the aircraft. Mostly nowadays, of course, you have something known as colored weather radar, where the color indication indicates whether the green, magenta, red, etc., are the various colors which indicate which are danger, which are, obviously the green color happens to be okay, magenta happens to be the cloud which is happen to be dangerous or likely to having more of turbulence. As I mentioned, the turbulence is totally related to the size of the water droplets in the cloud. Now, the principle of operation, the principle is the normal pulse technique in the help of the primary radar. Now, please, anybody in the class, I want an answer from the class now. What do you mean by primary radar? What do you mean by the principle is of the primary radar principle?
Is transmit and receive in the same frequency?
I want somebody else also to answer, please.
Okay.
I want somebody else also to give me the answer now to this particular question. Or next question, I don't want every time you're giving me the answer. The basic principle is you use the weather radar for specific, I mean, you transmit the radio, the so-called radio pulses. The radar is normally, the antenna is located in the nose of the aircraft, and you transmit from the nose of the aircraft uh, this beam strikes a particular cloud patch, and the return comes back, giving the picture, giving you the approximate range of a particular cloud, and you have a particular beam, a searchlight beam, of going rotating in front of the aircraft from 90 degrees to the left to 90 degrees to the right. It covers the complete area in front of you, and as and when this particular beam comes across a particular cloud patch, it will give you the information on that. That means the range and bearing of the cloud will be painted on your radar screen. Whether you're having a black and white radar or the color radar does not make the difference. Invariably, the frequency or the frequency used by the weather radar is 9375 megahertz, plus minus 30 megahertz, etc., etc. 9375 is the general frequency, plus minus 30. Now, if you try to find out if using this particular frequency, your wavelength will be approximately 3 centimeters. That means once you have selected a particular frequency for a radar, weather radar, airborne weather radar, the frequency allotted to this frequency weather radar is 9375 megahertz plus minus 30 megahertz. And if you do the calculation by application of CF lambda, you will find that the answer is approximately 3 centimeters. Why? Why we have selected a particular frequency for the weather radar? Now, somebody from the class, please try and answer this question.
Because of the size of the droplets, it's around 3 centimeters.
Exactly. Sorry, it is related to the size of the water droplets, right? As I said, all clouds are not dangerous. There are few clouds which are considered dangerous. And the size, the turbulence is totally related to the size of the water droplets. The larger the size of the water droplet, more will be the turbulence. Now, when we have selected a particular frequency, obviously we will be getting the returns also of the cloud or the size of the water droplet, which are larger in size, which happen to be turbulence. Now, suppose we have a frequency which is different than 9375, say a frequency which is very low, lower than 9375, what will happen?
It cannot detect.
Why? Reason. If you have a frequency which happens to be much lower than 937, that means your wavelength will be much higher.
Yes.
If your wavelength will be much higher, then obviously the reflection from the clouds will not be there. So you will not be able to receive any information. Or in case you increase the frequency, what will happen if you increase the frequency? Come on, ladies, I want to answer from the ladies now. What will happen if I increase the frequency?
Smaller water droplets, which is not
Okay.
very
Okay. Agreed. Absolutely agreed. Fine. That means you will get the response from the water droplets which are smaller in size. And you are not interested in that because that does not happen to be turbulent. So you will get the returns from the cloud. In case you increase the frequency, obviously you're if you're increasing the frequency, you are decreasing the wavelength. You're making the wavelength smaller than 3 centimeters. Now, as I said, the size of the water droplets starts from 1 millimeter and carries on up to 3.5 centimeters, right? So if you change the frequency, make the sort of wavelength smaller, you will get returns from the smaller water droplets, and they will clutter up your screen unnecessarily because these water droplets are not, repeat, not turbulent, neither dangerous. Okay, any questions, please? Now this is as far as the display is concerned. Now you have, depending on what particular range you want the information from, the range selection is available in the cockpit. You can switch on whatever particular range you want, and accordingly the range will be displayed according to whatever range you have selected. Normally 20, 50 and 150 are the ranges normally available, and you have got those so-called lines drawn on the screen giving you the. Now this is how the weather radar screen looks like. Right? This is how the screen looks like. This is, as I said, the antenna or the aerial is installed in the nose of the aircraft, displaying 90 degrees either side of the main heading or the 4.5 axis of the aircraft. Whatever information is available in front of the aircraft, the beam or the beam rotation of the beam is in such a manner that it picks up article 90 degrees either side of the center line. And you have a tilt. That means you can tilt the antenna up or down 15 degrees, plus minus 15 degrees. That means you can tilt the antenna up 15 degrees, tilt the antenna down 15 degrees. This you can control from the cockpit. You have a control switch which controls the so-called, when we talk about the tilt, you have a tilt switch. You can adjust the tilt depending on whether you have cloud above you or cloud below you. Now, I had given you, when we talk about the usage of the weather radar, one of the usages was to find the height of the top of the cloud. Right? Why? Why are we interested in height of the top of the cloud? Why can't we find the height of the base, or the bottom of the cloud?
Because we fly over it.
No, why? But why? What? There has to be a reason now. Why can't we fly below? Why are we interested in finding out the height of the cloud above you, the top of the cloud? The purpose or the reason or the usage of the weather radar is to find the height of the top of the cloud ahead of you. My question is, why not base of the cloud? Why are you interested in top of the cloud?
Because there is no turbulence above of the cloud.
No, it's not turbulence. It is the downdrafts, what we call them. Below the cloud, the downdrafts are very, very strong. As such, you are not permitted to fly just below the cloud. What is the purpose of finding the height of the top of the cloud now? We have found out, okay, the reason is that we are not interested in flying below because the downdrafts are very strong. Now, how do you use this particular information regarding height of the top of the cloud. You have found out, okay, now you are flying, you're sitting in the cockpit, you have found out the height of the top of the cloud is this is height is so and so in relation to your aircraft, right? How can you utilize this particular information? As a pilot, as a person sitting in the cockpit, how can you utilize this information? Anybody in the class?
We decide this information. We decide whether to fly above or around.
And can you change the rephrase the questions answer, please? Okay, I think you are getting on to the so-called right. What you are unable to phrase it in the correct manner. Idea is you have to find out whether your aircraft has got the capability to clear this weather. Can you climb 5,000 feet within this particular range? You know the distance, you know the height of the cloud, you know what is your distance from the cloud now. Is your aircraft capable of climbing this particular height? If you are not capable of climbing this height, you will have to divert either to the left or to the right to avoid this weather. So this gives you a clear indication when you talk about the height of the top of the cloud. This gives you a clear indication whether you can fly straight and clear this weather just by climbing above. The distance is enough, the range is enough for you to climb that particular height. And in case you cannot possibly hide that particular climb, then obviously you will be diverting the aircraft either to the left or to the right to avoid the weather. The purpose of finding the height of the top of the cloud is this. Number one, downdraft below you cannot find. As such, now you have found out the height of the top of the cloud. You decide whether your aircraft has got the capabilities of climbing this height within this particular range or no. In case no, obviously, you will be diverting the aircraft either to the left or maybe to the right. Now, when we talk about the various purposes we saw, there are four different distinct roles of the weather radar. Now you want to utilize the weather radar for weather purpose only. You want to use the weather radar for weather purpose only. As such, what you use is called the weather beam or the conical beam. Weather beam or the conical beam. You have got a choice. You got a selection on the control panel. You can select weather, and the weather beam will be transmitted from the aircraft now. Beam widths, etc., are clearly given you in the indication. The beam width is approximately 5 degrees, right? And you start transmitting what we term as the weather beam. I'll just show you. Yeah, this is how. Yeah, no, this one top on the top. Yeah, this one. Now, when you have selected the weather beam, the beam in front. Can you see the beam which is going straight? Is called the weather beam. This depicts the weather. This scans 90 degrees left and right. And whenever you pick up the weather, that particular weather is depicted onto the weather radar screen and will tell you, okay, you have the weather at so-and-so place. Simultaneously, in case of the weather beam, you transmit a beam which is called vertical over spill. You transmit a beam which goes directly towards the ground. It is called vertical overspill. And basically, just because of the primary radar principle, the beam will hit the ground and will come back, giving you the height of the aircraft above the ground. That means when you talk about the weather beam, once you have selected the weather beam, you are transmitting two beams at any given time. One happens to be the beam which will depict the weather, which goes straight directly, which has got approximately beam width of 5 degrees. And simultaneously, you transmit another beam, which is called vertical overspill, which travels directly below towards the ground and hits the ground and comes back, giving you the height of the aircraft. Can I go back, please?
Sorry, sir.
I can't control the beam now.
Can you move your cursor?
I am moving.
You say here you are controlling the screen.
Okay.
Okay, let me. Okay, can you try again?
No, nothing. No movement at all.
Okay.
You control. You control.
Yeah, okay, sir. Okay. So,
We go on to the page.
okay, sir. Seems like you accidentally close this one. Okay, which page, sir?
Okay. Next page, please. Next page. Yeah. We are on this particular page at the moment. You are just slightly below. No, you're going much ahead now. Go back. Please go back. Go back slightly further. Slightly. Okay. Carry on moving. Yeah. Now we are talking about this particular beam now. Okay. These are the radar beams as I mentioned, right? Now, one of the requirements in obviously in radar, as I mentioned slightly earlier also, when you spoke about the basic principle of the radar, the beam should be as narrow as possible. As such, in case I said the larger the size of the antenna, the narrower is the beam. We can do nothing much as far as the size of the antenna is concerned in the aircraft. As such, we are using the frequency, which has happened to be 9,000, closer to 9,000, right? Now, can you move forward, please? Up. Now, once you are, initially what happens is, okay, this is known as water and ice and the redome. Now, these are normally you're protected by the glass. Your so-called antenna in the nose of the aircraft is protected by a thick particular glass. You are normally operating at say 40,000 feet, 35,000 feet. The temperatures are very, very low. And what happens, ice formation takes place around the dome. And once you switch on the weather radar in the aircraft, initially nothing will happen, giving you an impression as if your weather radar is dumb. No image, no screen, absolutely blank picture will be there on the screen till the time the ice, once you switch on, you generate heat, and once the heat is generated, the ice around the dome starts melting. Once the ice has melted, obviously you will be able to radiate the radio beam thereafter as such, and we'll get the information. So once you talk about the water and ice on the radome, is basically is because you are flying at very great heights. As such, ice formation takes place. This ice takes a certain amount of time to get melted, because of the heat, and it takes certain amount of time. Initially, you will have no information. Your screen will stay blank and giving you an impression as if nothing is there. But it takes, after a certain amount of time, the information will be automatically displayed on the screen, right? Now this happens to be the so-called weather beam. What you see on the screen, vertical overspill. Now this, can you move forward, please? Move forward. Okay, forward. Yeah. Go ahead. Good. Go ahead. Oh, yes. Oh, yeah. I want to see the complete picture. Yeah, this one.
Okay, this one. Huh?
Yeah.
Okay.
No, I want to see the complete picture on page earlier on. Initially, the very first picture of the radar screen. You'll have to go a bit back, please. Go further. Go down. Yes, back. As far as you can. I'll tell you when to stop. Carry on. Okay, stop there. Now you see at the bottom there are two rings, two semicircles. Well, the range measurement starts from the first semicircle, and you have two semicircles. There is a gap between, or the distance between the first semicircle and the second semicircle, which gives you the height of the aircraft. As I said, in case of the weather beam, you have a beam which transmits a vertical overspill directly towards the ground. And this beam, after striking the ground, will come back, giving you the indication at what height you are operating. Depending on the height you are operating, the second semicircle at the at the base, at the bottom, will give you what height you are operating at. So the distance between the first semicircle and the range measurement starts from the first semicircle. Second semicircle gives you the height of the aircraft. Is this clearly understood? Hello?
Yes, clear.
Okay?
Yes, sir.
Okay. Now, can you move forward, please? Yeah, okay, now. This happens to be, we spoke about the weather beam. Now this happens to be the mapping beam. Mapping beam is entirely different beam now. It is called mapping beam. Now you want to use the weather radar for the purpose of map reading only. Weather happens to be reasonably okay. You do not want to use the weather radar for weather purpose, but you want to utilize this weather radar for mapping purpose, right? Now mapping purpose, if you see, the spill of the beam is almost 85 degrees. You're transmitting a particular beam from the aircraft. You have selected the mapping beam, and the area it covers is very, very large. As such, if the area is very large, obviously the beam is not very strong. The echoes coming back will not be very strong. As such, when we talk about the mapping beam, map reading can only be carried out with this particular beam up to a distance of 60 to 70 nautical miles only. $60 to $70 nautical miles only. Hello? But you were, 1 minute. Dad is sending me the lunch.
Then we have to for lunch, that's where we come.
Okay. Now this particular beam map reading can only be carried out up to a max distance of 60 to 70 nautical miles because the spill of the beam is 85 degrees. As such, the beam is very weak. Echoes are very weak. As such, the strong returns will not come back. As such, map reading is not feasible beyond the distance of 60 to 70 nautical miles. But if you want to utilize, or if you still want to carry out the map reading beyond the distance of 60 to 70 nautical miles, you will have to use the weather beam tilting downwards. I repeat, if you still want to carry out the weather, you want to read the weather, or you want to read the so-called map, beyond the distance of 60 to 70, you normally can't use 60 to 70 nautical miles. But if you want to utilize the so-called map reading facility beyond the distance of 60 to 70 nautical miles, you will have to use the weather beam. There is slight disadvantage of using a weather beam for map reading purpose. Can anybody in the class identify what could be that particular disadvantage? Anybody in the class?
Is it the effect of water and ice?
No, it is, the reason is because the coverage area, the beam width is only 5 degrees. As such, the coverage area will be very, very limited on the ground. Normally, for map reading purpose, you need a wider area to carry out the map reading to compare the features on the ground. On the mapping beam, this is possible because this field is 85 degrees. Now you want to map read beyond a particular distance of 60 to 70 nautical miles, and you want to use the weather beam. Obviously, if you see, the beam width is only 5 degrees. That means that on the ground, you will be covering a very limited area. As such, map reading will become slightly difficult if you use the weather beam for map reading purpose. Okay?
Okay, sir.
Anybody, any questions, please, so far?
No, sir.
Okay. Now, if you have no questions, now we have another circuit added to the weather radar, which is called ISO echo contour display. Can you move forward, please? You got the controls now? Yeah. This is ISO echo contour display, valid up to a distance of 50 nautical miles only. This particular contour display is valid up to a distance of ISO echo contour display, especially applicable to black and white radars. Now, once this particular circuit is in operation, once you have switched on, I said, if the size of the water droplets is approximately 3 centimeters, the returns coming back will be extremely, extremely strong, giving you the picture that strong returns are coming back. What happens in this particular case once you introduce or once you use the ISO echo control display, strong returns coming back are automatically screened or sort of intercepted at the receiver level itself. On the screen, no picture is painted of the returns which are very, very strong. If you have the ISO echo circuit display in action, that means if you have switched on the ISO echo circuit display, then and you're using the black and white radar, the strong returns coming back are nullified at the receiver itself. And can you show me the next display, please? Move forward, yeah. Now the picture painted will be something like this. What has happened is these so-called hollow circuits are giving you the indication that these are where the returns coming back are very strong. This cloud, this area happens to be very, very turbulent. If you have the ISO echo circuit display system on, then the strong returns coming back from the cloud are neutralized at the receiver, and receiver will not receive any information. As far as the display is concerned, the display will be something like what you see on your screens now. You will have those so-called hollow squares. If you have these so-called hollow squares, that means this is an indication to you that this is the area where the turbulence is likely to be very, very strong. Avoid this area of cloud where you have these so-called patches which are creating a sort of a hollow, giving you absolutely no information, as if there's nothing is there. But this is because of the ISO echo circuit which you have utilized, and the ISO echo circuit main purpose is to nullify or to neutralize the strong returns which are coming back, not to be given indication, not to reach the screen. At the receiver itself, they are neutralized and nullified. These returns which are coming back, which happen to be very strong in nature. Righto? You have another control which is called, can you go slightly further up, please? Sensitivity time control. Slightly down. Now, the purpose of sensitivity time control is basically to give you, again, the range is up to 25 nautical miles is the range. This is another circuit which is added, which within the distance of 25 nautical miles give you a picture which is absolutely similar. It is called automatic gain control, and the cloud pictures are, if you have this particular circuit in display, the clouds appearing within 25 nautical miles, from 5 nautical miles to say 25 nautical miles, the picture painted will be similar. As such, you have to decide which cloud to avoid, which cloud not to avoid, by using the sensitivity time control. Next, obviously, is the most important aspect of the weather radar is going to, what we are going to discuss now, finding the height of the cloud. Finding the height of the top of the cloud. Are you ready now?
Yes.
Can we discuss this? This is
Okay.
called finding the height of the top of the cloud. Now, what you see on your screens is what you have to actually do is, once you pick up a particular weather, you rotate the tilt in such a particular manner that the top of the cloud touches the lowest part of the beam, as shown on the picture. You rotate the tilt in such a particular manner, that means the whole beam will move upwards now, and the lowest part of the beam will be touching the top of the cloud, as you see on your screens. Understood? This is the basic purpose is to find out the height of the top of the cloud. First, you rotate the beam in such a particular manner that the bottom portion of the beam is touching, the lowest portion of the beam is touching the. Now, as far as the height of the top of the cloud is equal to range into actual distance divided by 60. I repeat, range into actual tilt divided by 60. Range, actual tilt divided by 60. Now, as far as the measurement of the tilt is concerned, you always measure the tilt from the center of the beam. That means if the beam happens to be 5.5 degrees, the center of the beam will be 2.5 degrees up, 2.5 degrees down. As in this particular case, what you see on your screen here is that the tilt reading is 4.5 degrees up. If it is 4.5 degrees up, the beam itself is, thickness of the beam is 2.5 degrees. Left over 4.5 minus 2.5 is 2 degrees. That means the actual tilt in this case is 2 degrees. 2 into whatever the distance is, 45 nautical miles, divided by 62 into 45 divided by 60. 1.5 is the answer. 1.5 means convert into feet will become 9,000 feet. That the height of the cloud is 9,000 feet above you. Actual tilt into range divided by 60. Understood? We'll do a couple of numericals on this. I would like into class to understand this very, very, very clearly. Okay? Now, when we talk about the tilt, I said tilt above the aircraft, tilt below the aircraft. Tilt above is plus 15, tilt below is minus 15. That means if it is, if the center of the beam happens to be 5 degrees below the level of you are flying at, then the tilt is minus 2.5 or 5, whatever the case may be. Right? Now I want to do you people to do a couple of, have you understood? Then I'll give you the examples. Okay?
Yes, sir.
Okay, note down, tilt plus 4 degrees, beam width 6 degrees, range 100 nautical miles, flight level 250. I repeat, tilt plus 4, beam width 6 degrees, range 100 nautical miles, flight level 250. Please find the height of the top of the cloud.
So flight level, can you repeat again the flight level?
Flight level 250.
250.
That's 25,000 feet.
Sir, is it 24995?
2?
4995.
What is the answer? What are you getting the what is the actual tilt?
3.
Actual tilt is 3 degrees, 3 into 100 divided by 60.
Yes.
Recheck the tilt again, please. What should be the actual tilt?
Okay.
Your beam width is 6 degrees
Yes.
and tilt reading is +4.
So does the actual tip is 1 degree?
Yeah, exactly. 1 degree, one up, +1.
Oh, +1.
1 into 100 divided by 60. Range is 60 nautical miles. Oh, sorry, the range is 100 nautical miles. 1 into 100 by 60. There, have you got the answer? 1 degree, please.
I got 1.667.
Why? Where are you getting all these figures from, yaar? Your beam width is 6 degrees. That means 3 degrees up and 3 degrees down, right?
Yes.
And the total tilt is 4 degrees. If the total tilt is 4 degrees, that means 3 degrees will be used by the center of the beam,
Yes.
and you are left with only 1.
Oh, okay.
Okay, 1 into 100 divided by 60 will give you the height. You can add whatever answer you get to 25,000 feet, and that will be the height of the top of the cloud.
Oh, okay, sir.
Anybody else having slightest doubt in this, please? Understood?
Yes, sir.
Okay, one more numerical. Tilt +2, beam width 6 degrees, range 120 nautical miles, flight level 400. Repeat, tilt +2, beam width 2, beam width 6 degrees, range 120 nautical miles, flight level 400. Please find out the height of the top of the cloud.
So, is it the actual tail 1 degree?
I beg your pardon?
The actual tail, is it 1 degree?
1 degree what?
1 degree
It is 1, but
-1.
-1. Exactly.
Yes.
-1 multiplied by 120 divided by 60. That means the height of the top cloud is lower than your aircraft.
Okay, sir.
Has everybody else understood this particular logic? Anybody in doubt, please?
So -1 times 120 divided by 60, we got -2.
Yeah.
So then we
No,
deduct
actually,
from,
the beam width is 6 degrees.
okay.
If the beam width is 2 degrees, that means the center of the beam, that means 3 degrees up and 3 degrees down.
Okay.
The center of the beam will be 3 degrees up. Total
Okay.
tilt reading is 2 degrees. That means
Okay.
the lower portion of the beam will be below your level.
Okay.
Whatever level you are flying
Okay.
at, that will be tilt will be -1.
Okay. So minus 1 times the range, 120
Yes,
divided by
exactly.
60. We
Yeah.
got
That means you have
minus
to
2.
subtract whatever from 40,000 feet, you have to subtract this particular height, whatever you're getting. That will be
Okay.
the height of the top of the cloud.
So the answer is 380.
Yeah,
Flight level
exactly.
380.
Something like that.
Oh, okay.
Anybody in the class in doubt as far as this numericals are concerned? One more, try one more. Tilt 0. Beam width 4 degrees. Range 60 nautical miles. Flight level 360. Again say tilt 0. Beam width 4 degrees. Range 60 nautical miles. Flight level 360. I want somebody else to give me the answer now, please.
Flight level
Are they-
340.
Adit, can you give me the answer, please? You do the calculation now. You're the only person I can see on the screen. Try. It's not difficult at all. Beam tilt 0, beam width 4. Oh, what a wonderful. बाद में बात करेंगे सर ये इसका 1 minute please stand by सर ये कल का खाने के लिए you'll have to
Okay, 358.
tomorrow this will do later sir please I don't even remember now okay नहीं है मैंने नहीं ये okay I'm so grateful to you अच्छा बात yeah I told you I'm going there
That's told me you will not be able to get it. I said, I'm sure that one will get it for me.
अच्छा सर वो सीसम ऑयल क्या होता है what is सीसम ऑयल
Sesame oil. Till
का तेल वो अवेलेबल है it's 30 rupees a liter I mean in case next time if you want I'll buy it. I just wanted to know the rate because it is 30 too expensive I found it too expensive
buy it for me.
वो केरला का प्रोडक्ट है
Buy it for me.
okay I'll do that I'll buy it thanks सर ये कल उसका छोटू का ले हो गया हम लोग ले गया हैप्पी क्लास चल रहा
So is the answer is flight level 358 or 340?
I beg your pardon
So is the answer is flight level 358
358
or 340?
what the tilt is 0 that means
0.
what will be your actual tilt in this case
Minus 2.
minus 2 minus 2 into 60 divided by 60
Okay.
and what minus 2 means
So we have
60 will minus 2 answer is minus 2
Okay.
converted to height or converted to in feet 2 into
Okay.
12,000 feet
12,000.
12,000 na?
Okay.
So 360 minus 12
240.
exactly 240 will be the height of the aircraft
Okay.
or height of the top of the cloud
Okay.
Is the class with me, or any case, in case you are a bit confused, we will try and do these numericals on your own. These are important, these are relevant, because even in your examinations, invariably you are asked one odd question on the height of the top of the cloud. Okay? Now, a question to the class. You are flying the aircraft and you are using the weather radar. The beam width is 5 degrees. The height of the top of the cloud is at your level. The height of the top of the cloud is your level, beam width is 5 degrees. What would be your tilt reading? The height is top of the cloud is at your level, beam width is 5 degrees, and what would be the tilt reading in this particular situation?
Is it 2.5, sir?
It is 2.5, but you always must say plus or minus. Always say, whenever we talk about the tilt, you always use the term plus or minus. It is 2.5 plus 2.5. Anybody else? Any questions regarding this whatever finding the height of the top of the cloud, what we discussed today? Okay. Questions, doubts, clarifications, if any, by anybody in the class, please. Okay. Hello,
Okay,
say
sir.
something. Okay,
Okay, sir.
now we talk about the use of the weather radar, especially on the ground. There are you can use the weather radar on the ground, but with certain precautions. What happens? Suppose you are operating from, say, any aerodrome. Suppose you are operating from Kuala Lumpur, and on the ground itself, weather happens to be bad. You want to use the weather radar right from the word go. Even before you take off, you want to use the operating precaution. Yeah, that's all. When you talk about the operating precautions, these are the operating precautions in the aircraft. Now, as I said, you can utilize the weather radar on the ground, provided you take certain precautions. Now, you wanted to take off from Kuala Lumpur, weather happens to be bad there, and you want to utilize the weather radar right from the word go. Right before you take off, you want to use the weather radar. As such, You know, these precautions, when we talk about precautions, there are two main precautions. There is number one, there is a position in the control panel which is called standby. If everything is totally on and you are on position which is called standby, you do not radiate any radio energy from the weather radar. Otherwise, system is on and can be utilized anything. But once you select a position which is called standby, everything is on, but no transmission of radio energy will take place. You are not to carry out any transmission if you have any obstruction within 100 feet of the aircraft. You are not supposed to carry out the transmission from the aircraft in case you have any obstruction in terms of building, aircraft, or human beings, or car parked, etc., etc., etc. Any obstruction within the 100 feet, the reflections coming back will be extremely, extremely strong. And these are likely to damage your weather radar crystals. If you have any obstruction within the 100 feet on ground, if you want to use the weather radar, as I said, the position is standby. Number two, never ever use the mapping beam on the ground. Never ever use the mapping beam on the ground. Always select the weather position, and that too on the standby mode. As soon as you line up on the runway, you can switch on, because there obviously there are no obstructions thereafter. You can switch on to the weather beam and carry on with the normal transmission. Once you have lined up on the runway, obviously there are not going to be obstructions. So the precautions are, do not radiate any radio energy from the weather radar if you have any obstruction within 100 feet. Any construction, any building, any aircraft, etc., etc., within 100 feet, the strong returns coming back will be extremely, extremely strong, which are likely to damage the crystals. Number two, if you use the mapping beam on the ground, obviously you are sitting on the ground, and if you're using the mapping beam, the returns coming back will be extremely strong. Not only damage the weather radar, will also damage the people sitting in the aircraft. Will harm the people sitting in the aircraft. These are the precautions you have to take. That means you have to put the aircraft on standby mode till the time you line up. Once you have lined up, weather beam, you can start radiating, transmitting once you have lined up. Obviously, once you have lined up, there are no obstructions thereafter. That's all for the day. Nothing more. Remaining portion of the weather radar I'll discuss in the next class.
Okay, sir.
Questions, doubts, if any, you can raise it now, or you can use it in the next class.
Okay, sir.
Right on?
Okay.
Okay. Question also we will do in the next class, and I'll try and complete the weather radar as far as during the next period.
Okay. So our class will be tomorrow.
I don't know whatever the timetable is. As per your timetable, I'm ready. I'm available if you want me to take the class tomorrow, day after. But I believe, as per the timetable which I got from Shakil, is I think day after tomorrow.
No, sir. It's been changed to Thursday because on Friday there will be a Good Friday. So Captain Don is going to church, I think.
Okay.
Yeah, so we'll be having class tomorrow, sir.
Okay. Then I'll same 11:30.
Yeah.
11:30 to 1 o'clock. I'll have the class tomorrow.
Yeah. Yes,
I'm ready.
Okay.
Okay.
Okay, sir.
Thank you. Thank you so much. Stay good. Stay happy. Stay
Thank
good.
you, sir.
Thank you, sir.
Stay healthy.
Have a good day, sir.
Don't do anything which I'm not supposed to be doing.
Thank you, sir.
Okay. All the best.
Okay. Have a
Thank
nice
you,
day, sir.
sir.
Thank you.
Thank you, sir.
Thank you.
Thank you.